In the problem number 26, we need potential difference between P and Q. P and Q is a part of the circuit as shown in the figure. So in this question, we will use the Kirchhoff's law, and I am going to consider my mental direction is P to Q and the direction of current also along P to Q. So we'll use the proper sign convection. P minus IR means current is 3, resistance is 1. You are moving positive to negative plate, we'll write minus 2, and minus 2 into I means 3, minus 1, that is equal Q. So when you will calculate P and Q on solving, you will get 12 volt. So this is a basic question. So option number 4 will be the right choice. Let's move on. Question number 27. In the 27, 1600 watt 180 volt heater operate at 180 volt. The resistance of the heating coil. Question is asking to us resistance of heating coil. So I will use the formula of resistance V square by P. You can put the value directly, 180 square 1600. On solving you will get 20.25 ohm. So my option number first will be the right choice. So let's move on. 28. A flow of 10 to the power 12 electrons per minute, okay, in a conducting wire constitute a current. So in the case of current, when number of electrons are given, we'll use NE by T. Number of electrons 10 to the power 12. Charge on 1 electron 1.6 10 to the power minus 19 coulomb. Divide by the time per minute. So I am going to take per second. So on solving we'll get 2.67 10 to the power minus 9 ampere. So my option number third will be the right choice. So we'll go question number 29. In the problem number 29, Kirchhoff's first law at a junction is based on conservation of charge, because at the junction cannot create the charge and cannot absorb the charge, because incoming current will be equal to the outgoing current. So option number third will be the right choice. Let's move on. Question number 30. In the problem number 30, a wire of resistance 10 ohm stretched to twice its original length. The resistance of half of the stretched wire is. So in the case of stretching wire, volume will remain constant. So we will use this, and I can write final resistance to the initial resistance, and that is final length with square, initial length will square. Final length will becomes twice, so we'll get 4 upon 1. And if I go for final resistance, then 4 times of initial resistance was 10. So you will get 40 ohm. But question is asking to us half of the stretched wire. So in the case of half of a stretched wire, you can half the final value. So we'll get 20 ohm. My option number 2 will be the right choice, 20 ohm. Let's move on. Question number 31.